we want to use the limit method to find the horizontal asymptote for f of x equals x over radical x squared plus 1. Okay, we know what the limit method is, right? We need to find the limit as x approaches infinity. But this one is a little bit tricky because, well, when you look at the denominator, what is the leading term in the denominator? It's not x squared. It's radical x squared. But the trick here is radical x squared is actually just it's plus and minus x, right? So it's possible that x is positive, but it's also possible that x is negative, right? So in this particular case, whenever we want to find the limit, okay, actually if we want to find the limit as x approaches positive infinity, we need to divide by the positive square root of x squared, right? Because that's the leading term here. But if you want to find the limit as x approaches negative infinity, we need to divide each term by the negative square root of x squared, okay? Because of this property right here. Okay, so in this case, let's just find the limit as x approaches infinity. So we're going to take the x over radical x squared, okay? And then on the denominator, radical x squared plus 1, and divide that by radical x squared. Okay, now this one, okay, this actually just cancels out, right? Radical x squared is just, well, it's just x, so that just equals 1, right? But what happens on the denominator, right? Here's where you're going to be a little bit tricky. Here, we can use the actual property for radicals, right? And combine this into one radical here, right? Radical x squared plus 1 divided by x squared. And now we can split this guy up, okay? So let's just write it down here, right? We still have the limit as x approaches infinity. We still have that 1 on top, but notice here we have now radical x squared over x squared plus radical 1 over x squared. Okay? And now we should be able to simplify this, right? Wait a minute, that's just equal to 1 right there. Okay, so we have the limit as x approaches infinity of 1 over 1 plus 1 over radical x squared, which is just x. Okay. All right, so now we can take the limit of each piece of this guy, right? We're going to use the limit laws. So we have the limit as x approaches infinity of 1 divided by the limit as x approaches infinity of 1 plus the limit as x approaches infinity of 1 over x. Okay. And using the rules that we know, this is just a constant, right? So this just equals 1. Here, this just equals 1, and this, as we've learned, right, as x gets really, really large, 1 over a really large number, that's just equal to 0, right? This goes to 0. So what's the final result here? We get 1 over 1, which is just equal to 1. So this limit, okay, the limit as x approaches infinity, in this case, well, we're just going to equal positive 1.